Okay, trig, no, quite a chunky trig question by the looks of it. Part A, find all values of theta in the range 0 to 360 inclusive, satisfying this. Now, trig identities immediately here because we have some sines and we have some causes, and you can't have both. Well, very unlikely that you'd have both. As a reminder, there's one particular identity that's going to be useful for us here. We have sine squared plus cos squared equals 1. Please bear with me. Knock at the door. Right, sorry, apologies. Had a visitor all over now. Right, so this is the trig identity. That's where I was leaving it. Sine squared theta plus cos squared theta equals 1. Far more useful if you rearrange it. Two possible ways. Sine squared equals 1 minus cos squared. Or cos squared equals 1 minus sine squared. Excuse me. Now, if we look at this equation here, I'm going to choose to use one of these identities to make this all either sine or cos. Now, I have a sine squared, and I have a sine, and I have a cos squared. So this is what I'm going to choose to replace. So it is consistently sine throughout. So instead of that, I'm going to put in that. So this becomes 6 sine squared theta plus 1 equals 2. Instead of cos squared, we're going to now have 1 minus sine squared. But there was also that minus sine theta on the end. This is a quadratic equation. We're rearranging to do 6 sine squared theta plus 1 equals 2 minus 2 sine squared minus 2 sine. Rearrange 8 sine squared theta plus 2 sine theta minus 1 equals 0. Okay, so what we have here is a quadratic we're going to need to factorize and split down the middle. So it's going to be 8 times minus 1 is minus 8. Your factor pair is 4 and minus 2. This one, it doesn't actually matter which side they go on, but I'm going to split it. Remember, it starts with 8 sine squared. You may prefer x instead of sine theta. It's up to you. I'm going to go for plus 4 sine theta minus 2 sine theta and factorize. So it's going to be 4 sine theta brackets 2 sine theta plus 1. And then I can take a minus 1 outside here to give me 2 sine theta plus 1. So you have 4 sine theta minus 1. Sorry, 2 sine theta plus 1, which means that we have sine theta, because they were equal to 0, of course, sine theta equals a quarter, and sine theta equals minus a half. Now, finding those values on the calculator by using sine to the minus 1 will give us sine to the minus 1 of 0.25, which is 14.5. Does it say anything about decimal places? No, so I'm going to go for 14.5 degrees. And the other one, you have minus 30. Okay, using those, we can do 2 separate cast diagrams because they are not the only solutions in the range 0 to 360. Obviously, the graphical method is also available. I'm just going to go up here, by the way. The graphical method also available. I tend to go for cast. I'm going to go for 2 separate cast diagrams as not to confuse myself. C A S T C A S T. So for my first one, for this solution of 14.5, the value of sine theta was a quarter, and a quarter is positive. So I want where sine is positive, which is here and here. In the other one, I was finding sine theta of equal to minus a half. So sine is negative. Now, with the first one, actually in both, the range is 0 to 360, so that's both in this anti-clockwise direction here. So there and there, and in the other one it's there and there. The first one tells us that this acute angle here is 14.5. In this second one, it's telling us that this angle is worth 30 degrees. That's what this minus 30 here means. That doesn't mean that that's an answer though. That just means the size of that angle is worth 30 degrees. I'm going to use angle facts to work out the rest. So from the first one, I get 14.5 as my first solution to there. And then this next one is 180 take away 14.5, which is 165.5 degrees. And then this one, you have this one here is 180 plus 30, which is 210. And then we have 360 take away 30, which is 330 degrees. So part A is taking up a lot of room. I may need a separate slide for this one in a moment. Part B, we'll see if I can squeeze in here. Find all values of x in the range 0 to 180, so quite a small range, satisfying tan of this equals minus 0.81. Now, when it's not just x and it is something else within this bracket of tan, that means that we're going to have to do something to the range, first of all. Okay, maybe our first step would be let y equal 3x minus 57. So it looks a little bit easier. We have tan of y equals minus 0.81. And actually, maybe why don't we just work out tan to the minus 1 of that first? So we have tan to the minus 1 of minus 0.81, which is going to give us minus 39 degrees. Now we could go straight into the cast diagram with that, but what I think we maybe should do is adjust the range first. So the range was 0 to 180, but that was for x. I'm talking now about y. So if the range was 0 to 180 for x, then if I'm doing y, then I need to times it by 3 and then take away 57 from both sides. So if I take, if I times 0 by 3 and take away 57, it's just minus 57. If I have 180 and I times that by 3 and then take away 57, it's 483 degrees. So that is the range that I need to consider for this minus 39 degrees. Cast diagram in this space here, C, A, S, T. Now, I was talking about tan of y equal to minus 0.81. That's where tan is negative. Tan is negative here and here. And what it's telling me is that this angle here is worth 39 degrees. And also this angle here is worth 39 degrees. Now, I want any in this range only. And there are actually a few different answers here. So if I go around in the positive direction, then this one would be included, as would that one. And that's it. If I go beyond 360, which I can, I will find another one, which, well, a bit of mental arithmetic can tell me whether that's going to be included, because if I go to 540, which would be this line, and I take away 39, it's going to be a little bit too big. It's going to be just outside that range. It's just those two. However, that would be just for the range 0 to 483. This one is the range of minus 57 up to that. So I can also go in this negative direction as well. And this would be included. So just to clarify for my y answers, y, I would have, first of all, this one here, which is 180 take away 39. I would have that one there, which is 360 take away 39. But also I'd have this negative one here, which is negative 39. So in numerical order, I'll put the minus 39 first. Then I would have 141. And then I would have 3, 2, 1. Now, those are my three answers for y, but let's not forget that we changed the range to include y. So now if I want to go back to x, I need to do the opposite things. So for each, so if those are my three y answers, for my three x answers, to go back to what I had initially, well, I did times by 3, take away 57, reverse those directions, take away 57, divide by 3. So minus 39, oops, excuse me, minus 39. Oh, sorry, what did I say? I'm going to add 57. Then I'm going to divide by 3 to give you 6 degrees. 141, now I'm going to add 57, divide by 3. 141 plus 57, divide by 3 is 66 degrees. And then 321 plus 57, divide by 3 is 126. This suggests we've done it right because those three answers are all within the range 0 to 180. Apologies for the state of this one. There's a lot going on in this question. Part C, give me 1 marker. Without carrying out any calculations, explain why there are no values such that this equation can happen. Now, unusual question, but the fact that this equals minus 7 is really important because what we have is sine and we have cos. And sine and cos, the maximum values of each of them and the minimum values are either 1 or minus 1 if we think about graphs. Is it possible to get an equation here, so when I do 2 times this plus 4 times this, and it gives me minus 7? Well, if it's going to be minus 7, I want this and this to be as small as possible. And if they were as small as possible, that would be minus 1. 2 times minus 1 plus 4 times minus 1 is only minus 6. Therefore, it is not possible to get minus 7 because I can't get any smaller. So you would need to write that into some words. I'm not going to type it on here because I don't trust my pen and my writing necessarily. You need to say that the minimum value of both sine and cos in this situation is minus 1. Therefore, the minimum value of the overall equation is minus 6.